Well, this week I got a new haircut and made some billet window cranks. So it turns out these were actually a little bit trickier to machine than I thought. Also, the fitment was a little bit more difficult than I thought. When I first designed these, I started with the factory plastic part, took some measurements off of the car, and then I found an average between the two fitments, and then I drew all the geometry based on that. After machining the first few and test fitting the first few, I realized that fitment is a little bit different between vehicles. Also, fitment between the left door and the right door was a little bit different. Because the left window gets used much more in a Corolla or other older Toyotas, that spline actually starts to wear. So my original measurements were taken off of the spline on my driver's side door. I made it fit super nice, and then it would not fit on my passenger side. So back to the drawing board, open up the spline a little bit, and found the best of both worlds so I could make these better than the factory ones, a little bit tighter than the factory ones, but not so tight that they're difficult to get on and off. Another thing that I ran into when I was machining the spline for the Toyota ones is it's a 16-point spline, and using the 16th end mill that I showed you guys, cutting out that spline was a little bit tight. So what I ended up doing was removing half of the spline count, so only every other spline is engaging in the door. Sounds a little strange, but because the part's aluminum and not plastic, it is extremely strong still. They're not worried at all about the strength of the splines, but it did increase the efficiency in the machining so I can make them faster, and the quality of the spline is actually a little bit better as well. So last week I was talking about finding a way to hold the bearing inside. What I ended up doing was just using a snap ring with a snap ring groove. I added a step here of about 100 thousandths so that I could make room for that snap ring. This step also helps to hide the hardware, so the hardware that's in here is now going to sink down below this surface. If this were to ever come in contact with the door panel, the hardware would not be rubbing. Even though it's button head hardware, you still don't want it to be touching anything. The snap ring is designed for a 3/4 inch diameter and it's 1 millimeter thick. Fortunately, when you're designing something for a snap ring, usually the manufacturer gives you the specifications for the diameter that this needs to go into and the diameter that it snaps out to. So there's really no guessing when it comes to designing a part to fit a snap ring. You just sort of copy what they tell you to do. We've got the knobs all finished. This is a Delrin one. The last two pieces are the bearing. This is a stainless steel ball bearing with a rubber seal on both sides, and the M6 by 18 millimeter stainless steel button head screw. These are really nice quality. And the final assembly. After working through the whole week to get these cranks finished, we did end up releasing them on Friday, which was really cool. We ended up selling a little bit more than we had bought material for originally, so I ran down to the metal supply store on Saturday, picked up more material, and now what we're going to be doing this week is hustling and getting as many of them done. Because we offered some of them in black anodized, we got to get all of those out to anodizing as quickly as possible so that we can meet our lead time, which I put as 2 weeks, but we'll probably have them shipping out in about a week. Another thing that I changed that I didn't talk about while I was designing these was offering different knobs. Originally it was going to be an all aluminum crank, but there were quite a few people that sent messages and made comments about, oh, I live in a hot area, what if this thing gets hot? So we decided to make some out of Delrin, and that is an option as well. So people can buy them in raw aluminum with a raw aluminum knob, black anodized aluminum with an aluminum knob, or either of those options with a Delrin knob. I kind of like the way that the raw with Delrin looks, because while I was going through all of my test fits, I test fit on a TE27, and this is the factory window crank from a 1973 Toyota Corolla. You can see the resemblance. So this is a chrome-plated aluminum casting with a plastic and rubber knob on it, but it kind of represents a very similar look to the Billet one with the Delrin knob, so I think that that's kind of cool. Here's the Billet crank and the stock AE86 crank. You'll notice that I added the detail of the line that follows the inside edge of the part. This is just to make it look similar to a lot of the 80s and 90s Toyota cranks. On the back side of the factory crank, there's a lot of pocketing in here to obviously save weight and probably save cost of the plastic that they use to make it, but I also incorporated some pocketing on our aluminum one. So I removed a lot of material around the outside. It doesn't affect the look on the outside of the crank, but on the backside or inside of the crank, this actually cut quite a bit of weight out of it. You can actually feel the difference when you're holding the two in your hand. So let's go head out into the shop and I'll show you guys the process of manufacturing these so you can see how it's going. I'm running the main part of the crank on the VF2. It's sort of my go-to universal machine because it has the most amount of tools in it. Also, it was the one that was available. Most early production goes something like this, where I stack all the material on one side of the table, and then all of the finished parts that either need to get deburred or sent over to the assembly area go on the right side of the table. If they can, they'll go into egg cartons. Remember that really fine spline that I was telling you about and how I had to use a long 1/16 end mill to cut it? Well, here's what it looks like in the machine. This is an 1/8 inch shank, 1/16 end mill, reaching 1/2 inch cutting or flute length, and it's relieved a little bit at the very top just so that I can have a little more tool clearance. So this tiny little tool has to go inside here and cut out that spline. What this is doing is a ramping contour. So it's doing a circular pattern counterclockwise and working its way down the bore. This way I'm not putting very much side load on the tool because that would break it for sure. After all the milling work is finished, the last tool that comes in is a chamfering tool, and what that does is it goes down and it cuts off the sharp corners on all of the edges, and it cuts a 45-degree angle. You can see it going around the part, just breaking off all the sharp edges. For the knobs, I just decided to go with the simplest route for making them for me, which is just in a 6-inch vise, op1 and op2 in the same set of jaws, op1 on the left side to do the top of it, op2 on the right side to do the bottom of it. One at a time. It's a pretty slow process to make a bunch of these, but anytime we have a new product, I just want to have a minimal viable solution for manufacturing, and this is the easiest thing to do. If these start selling well and I need to start making more of them quicker and more efficiently, then I can come up with some fixturing to do that. But for a first batch, it's usually just one like this. We're running these knobs in both aluminum and Delrin, so when customers check out, they can choose either a raw aluminum, an anodized aluminum, or a black Delrin version of the knob. This material is for something I'm going to show you guys next week. This is actually one of our customers that we manufacture parts for. We don't do a lot of job shop work, but this is a close friend of ours and we make an exception for him. What he does is he manufactures replicas or remakes Racing Heart center cap nuts and dishes for old Racing Heart wheels. I'll get into that next week. Lastly, I got a lot of questions about the oil catch can and what the progress was, when we were going to have a release date on it. What's going on right now is our 1-inch breather filter finally showed up, so I can work on the design of this later this week, get all of this stuff finalized, figure out that bracket, and hopefully start machining something by the end of next week, maybe the following week. I'll probably want to go do some more testing. I'll put one in my car and make sure there's no issues with the cooling tank, no leaks, make sure that it doesn't vibrate or have any other weird issues. And then we'll start machining. So maybe 2 to 3 weeks we'll start machining these. I'll keep you guys updated. See you guys next week.